So let us move on to question 1.2 of first chapter. So I'll read out the question. Check permutation. Given two strings, write a method to decide if one is a permutation of the other. Right. So this can be solved using two approaches. One which I have written on the screen, which is first we'll check obviously. This is an obvious step. So first we check if the length is equal. If it is not equal, there is no point of it being the anagram because it cannot be. For being an anagram, the length of both the strings should be the same. So if they're not equal, then we return false. Right. Then we sort the arrays like we did in the previous question 1.1. We sort it. If S is equal to T, we return true. Obviously, it is sorted. And if it is true, then obviously we return true. Otherwise, we return false. So there is another method of we can use hash table, right? So to do that, first let us define an array. Define int array 26, right? And set each of them to 0 first. Why do we use 26 here? Because there are 26 letters, right? Now we define int n, which is s dot length 5. So now we run a for loop. The time complexity of the previous code was n log n, right? Suppose, yeah, it is n log n, where n is the string length because we use the sort function. Now to optimize this thing, we are trying to use hash table where the time complexity would be O of n. Fine. So here we use for loop int I equals to 0, right? I is less than n I plus. Now what we do here exactly is a r of si minus a plus plus. I'll explain everything. T, just let me finish this once. T of I, no, not, yeah, again we have to use it. T of I minus a minus, right? Now we, again, now why we are doing this? First, the array which we defined, which is ARR, is 0, like 26 zeros. Now what we are doing, we are running through both the arrays. And if their indices are same, we we increment it by 1 for S string and decrement it by 1 for T string. Now just imagine if both the strings have the same letters. So the same letter which is corresponding to an index will increment in Sth trial and decrement in Tth trial. So it will remain 0. So now now we have to just compare I less than 26, I plus plus. Now if ARR I not equal to 0, we return false. Otherwise, we return true. Because if it's not 0, because if it's not 0, obviously means there are some elements in S or some elements in T which are not present in the other one. That's why. Now let us run this code and check if it passes the test cases. Oh, it doesn't work. Returns well. I should have checked. Right. I hope there are no errors now. Yeah, there are no errors. So yeah, there is the method. Okay, we can submit this one. So the hash table method is much more efficient than the sort method, right? Fine. Thank you for watching.